Okay, this video is meant for Jovin and Darshan who missed the lesson for probabilities. We should be referring to notes 4.2. Now turn to the second page. We last stopped at the concept of mutually exclusive events, and we said that mutually exclusive events are events that cannot occur at the same time. Moving on, we went through some real-life examples of mutually exclusive events. For example, in this particular case, events A and B are mutually exclusive because they cannot happen at the same time. You cannot be late for class and on time at the same time. These are what we call mutually exclusive events. Now let's have a look at more mutually exclusive events. Let's refer to the next page. You should be referring to activity 1. Now later on, we'll be covering this concept of the addition of probabilities for mutually exclusive events. So remember this, we are going to perform addition. Now in the activity 1 that you see below, a fair 6-sided die is rolled. Event A happens when the number that shows up is even. Event B, when the number is a multiple of 5. And event C, when the number is a multiple of 3. Now what are the possible outcomes for event A occurring? The possible sample space is consisting of the numbers 1, 2, 3, 4, 5, and 6. Now for event A to occur, you need to choose a number that is even, and that means we are considering the outcomes 2, 4, and 6. Now for event B, multiple of 5. Now multiple of 5 refers to numbers like 5, 10, 15, and 20. Now in this sample space, there is only one number that is a multiple of 5, and that is the number 5 itself. So 5. Event C, multiple of 3. Now 3 and 6 are both multiples of 3, so there are two outcomes, 3 and 6. So let's decide whether the events are mutually exclusive or not. Event A, event B, are they mutually exclusive? In other words, can they happen at the same time? Now in this sample space, is it possible to get an even number that is also a multiple of 5? I repeat, within this sample space, can we get a number that is both even and multiple of 5? Is there such a number? Now there isn't such a number. But because of that, events A and B cannot happen at the same time. We say that they are mutually exclusive. Okay, so yes, they are mutually exclusive. They cannot happen at the same time. Now what about events A and C? Now in the sample space that's provided, where you see the outcomes 1, 2, 3, 4, 5, and 6, can you have a number that is both even and also a multiple of 3? Now you realize we are talking about the element 6. 6 actually is both even and it is also a multiple of 3. Now because of that, we say that events A and C can happen at the same time. I repeat, event A and C, they can happen at the same time. In other words, they are not mutually exclusive. Okay, let's write that down. Now what does that mean? Let's carry on. Now to do this, we will now work out the probabilities of event A occurring. So the probability of getting an even number, it is 3 outcomes out of the possible 6. So 3 over 6. Simplest form, half. B, probability of B occurring, multiple of 5, so there's only 1 out of the possible 6. Event C, there are 2 possible outcomes out of the 6. So 2 out of 6, simplest form, 1/3. Probability of A or B occurring, that means can either be A or B. Now there are 4 of such outcomes, so 4 out of 6, which is 2/3. Probability of A or C, that means could be A, could be C. Now how many outcomes are there? 1, 2, 3, 4. Do we count this? Now we do not count this because the number 6 occurred here before already, so do not double count it. So how many possible outcomes are there for probability of A or C occurring? It's only 1, 2, 3, and 4. So 4 out of 6 as well. Sorry, it should be 2/3. Now, with all these probabilities, is there a connection between these 3? This one, and this one. Do you see a connection? In fact, shall we just focus on the non-simplified fractions? Look at these 3. Do you see a connection? Can you see that just now we mentioned A and B are mutually exclusive events? And the probabilities work like this. P bracket A plus P bracket B works out to be 3/6 plus 1/6. And by some coincidence, these 2 probabilities add up to equal to this. 4/6, which is the probability of A or B occurring. Now this is the addition property that I've talked about for mutually exclusive events. In other words, this is a formula that you need to know. When A and B are mutually exclusive events, probability of A or B occurring can be found by adding up the individual probabilities like this. Okay, remember this is important. This is the formula for this topic. Now what about the other side? A and C, just now we already said A and C, they are not mutually exclusive. I'm talking about here, right? We established they are not mutually exclusive. So does that mean the formula doesn't work? Now we do not know. Let's see. A and C are not mutually exclusive events. Okay, I just noticed that I missed out one word earlier on. They are mutually exclusive. Sorry for that. Okay, back to A and C. They are not mutually exclusive. Now let's test out whether the formula works. PA plus PC, let's work it out first. From the table above. Okay, let's find. Where is PA? PA is over here, this one. PC is this one. So 3/6 plus 2/6. P, A, or C from the table above is 4/6. Then you compare. Compare your left hand side and right hand side. Are they equal? And you should realize they are not equal. In other words, the formula doesn't work anymore. What we saw earlier on, the formula, doesn't work for the right hand side because A and C are not mutually exclusive events. To put it simply, we can now move on. When you have mutually exclusive events, the formula works. Okay, the formula works. Let's skip this first. We'll come back to this subsequently. Let's do some examples. We do together exercise 1. A club holds an election for the post of, can you add in, 1 chairperson only. So candidates Monica and Roland, if they are elected, the probabilities that they will win are 0.36 and 0.47 respectively. Find the probability that either Monica or Roland be elected. Now, do you realize that whether Monica or Roland gets elected, these are mutually exclusive events. They cannot happen at the same time. Why? Because we are only choosing one chairperson. Right, so it's either Monica or Roland. It cannot be the case where both of them are the chairpersons. As such, these are mutually exclusive events. Therefore, in part A, when they say the probability that either Monica or Roland are elected, these can be applied using the formula P bracket M plus P bracket R. Because we are talking about mutually exclusive events here, the formula works. And to calculate it out, I would take the 0.36 plus the 0.47, and the resulting probability is 0.83. Now, on the other hand, what is the probability that neither of them wins? That means somebody else wins. Probability that neither Monica wins nor Roland wins is 1 whole subtract 0.83, and that will be 0.17. That means somebody else is running for the chairperson role, but that person is not Monica, it's not Roland, it's somebody else, but the question did not mention. And actually, how do I know that there is one other person? If you just look at these two probabilities, do you realize that these two probabilities do not add up to 1 whole? They do not. And because they do not add to 1 whole, that means there is somebody else in the election that the question did not mention. And that's why there is a part B. Can you try this question by yourself? When you are ready, let's check the answer. Now, for this question, in the class tournament, only one winner. Okay, there can only be one winner. So again, we're talking about mutually exclusive events. Sam or Tim can win, but they cannot win at the same time. Now, probability that Sam wins or Tim wins, you can split the probabilities according to the formula, add up, and the result is 0.43. If they don't win, it is somebody else. You must take 1 whole to subtract, and that's how we got the 0.57. Okay? Now with that, we have practiced the formula for mutually exclusive events by splitting the probabilities of A and B, and we add them together. Alright? Now, with that, we have come to the end of 4.2. Now, the pages at the back are not so important. We will just stop there first, and let's move on to the next segment. The next segment will use notes 4.3, and we're going to jump back into probability tree diagram. Okay, let's stop the video now.